Hi everyone. Today we're going to be completing our notes on simplifying radicals. Before we talk about radicals, I want to start off with a warm up and just think about perfect squares. So, what I mean by perfect squares are what are the numbers that we can square themselves and get a whole number. So, we have our first one is if we take 1 squared or 1 times itself 2 times, we get 1 times 1 or 1. Our next perfect square is 2 squared. Well, 2 squared is 2 times itself 2 times, which is 2 times 2, 4. Our next perfect square, 3 squared, 3 times itself 2 times, or 3 times 3 is 9. Our next perfect square, 4 squared, is 4 times 4, 16. And go ahead and find the next perfect squares up to 10 squared. Go ahead and pause the video and fill in the warm up. Find the next perfect squares all the way up to 10 squared, and you can unpause to check your answers. The next perfect square is 5 squared. 5 times itself 2 times, 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, or 9 times 9 is 81. And last but not least, 10 squared, or 10 times 10 is 100. So now I want to talk about radicals and how these perfect squares fit in. Now, remember, 6 times 6, right? That's one of our perfect squares. 6 times itself 2 times is 6 squared, or we know that is 36. Now, a radical, in particular the square root, is this symbol right here. And if I were to say the square root of 36, I'm going to write the 36 inside that radical. What this means is we're asking ourselves what number times itself is 36? What number times itself equals 36? Well, we know the answer to that. What number times itself is 36? Well, we know 6 squared is 36. So therefore, the square root of 36 evaluates to 6. So let's go ahead and write that. The square root of 36 is equal to 6. It's like working in the opposite direction. If we're saying 6 squared is 36, we're going in the opposite direction now, and we're saying the square root of 36 is equal to 6. What number times itself is equal to that number inside the square root? So another example, if I were to say like the square root of 49, what number times itself is 49? The answer to that is 7. Or say the square root of 100, what number times itself gives you 100? The answer is 10. So let's go ahead and evaluate the following. We have the square root of 4. What times itself is 4? We have 2. What times itself is 9, the square root of 9? The answer is 3. The square root of 36, we've done that one, so that one is 6. 6 times 6 is 36. And last but not least, the square root of 81. What number times itself is 81? The answer is 9. So all of these perfect squares are going to be really handy. It's good for you to memorize each of these perfect squares. The more familiar you are with each of these perfect squares, the easier these problems will be. So remember these perfect squares. Now let's go ahead and simplify radicals that are not perfect squares. In order to simplify radicals that are not perfect squares, we follow 2 steps. The first step, step 1, is to rewrite the number inside the square root. Rewrite the number inside the square root as a product of one of the perfect squares and another number. Rewrite the number inside the square root as a product of one of the perfect squares and another number. So what we're saying is we're going to break down that number inside the square root. So like in example number 5, we're going to break down 28 into two factors, one of which will be one of our perfect squares. So one of our blue numbers here. Step 2 in simplifying radicals is to separate the square root and then simplify. Separate the square root, then simplify. So let's take a look at number 5. Again, step 1, we want to rewrite 28 as a product of two factors, one of which is a perfect square. So 28, I'm thinking factors of 28. Well, of course, we could say 1 and 28. We could say 2 and 14. We could also break it down into 4 and 7. We know that 28 is a product of 4 and 7. So I can rewrite this now. Instead of the square root of 28, I'm going to say it's the square root of 4 times 7. Now, step 2, we're going to separate this into two square roots. So the square root of 4 and the square root of 7. We can do this because we're multiplying these two. And we know what the square root of 4 is. That was our number 1. The square root of 4 is 2. And then the square root of 7, well, we can't take the square root of that. So we're just going to leave that as the square root of 7. And that gives us our answer, 2 root 7, or 2 times the square root of 7. We know we're finished because we can't simplify the square root of 7. And last but not least, the square root of 80. I'm going to break down 80. We could do 8 and 10, but neither 8 and 10 are perfect squares. Remember, we want to get one of our factors to be one of these blue numbers. So which one of these times another number gives us 80? The answer to that would be 16. 16 times 5 is 80. That's one of our perfect squares. So let's go ahead and separate 80 into its factors, 16 and 5. So we can say the square root of 80 is equal to the square root of 16 times 5. Step 2, separate those square roots. So the square root of 16 times the square root of 5. And we know what the square root of 16 is. That's why we found that perfect square. That evaluates to 4, and then times the square root of 5. So 4 root 5, or 4 times the square root of 5. All right. So these have been our notes on simplifying radicals. We'll get a whole lot of practice, so we'll see you. Have a great day, everybody.